Redox reaction. An oxidation-reduction reaction is a type of chemical reaction that involves the transfer of electron between two species. An oxidation-reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. Here is the equation of it. Oxidation number and its rules of assigning the numbers. Oxidation reduction reaction are reactions in which electrons are lost by an atom or ion. One reaction reactant and gained by an atom or ion in another reaction. Although electrons are gained and lost in these reactions, the balanced equation for redox reaction does not show the electrons that are being transferred. Oxidation number are hypothetical numbers assigned by the individual's atoms or ion atoms present in the substance using a set of rules. Oxidation number states can be positive or negative, or they may be a zero. It is very important to remember that oxidation numbers are always reported for one individual atom or ion and not for groups for atoms or ions. Now, the rule for assigning numbers are as the following rules for assigning it. Next one is a redox balancing chemical equation. Balancing simple redox reaction can be a straightforward method of going back and forth between product and reactant. For example, in the redox reaction of Na and Cl2, we have an equation NaCl2 and NaCl2. We both have a fixed and balanced and non-balanced equation there. And third one is a balanced equation 2NaCl, 2 into 2NaCl. Here is an example and here is a solution of it. And we have the types of redox reaction: decomposition, combination, disproportionation, and displacement reactions. Here is the explanation of all that. Now we have the application of redox reaction in electrochemistry. The battery which we use for DC current was used like we have a vehicle and all the process and work that vehicle performed just because of the DC current that we used, and the storage cell are used in vehicles. Redox reaction in combustion. Combustion is a type of oxidation reduction reaction, and hence it is a redox reaction. And explosion is a fast form of combustion, as we know. Just removal of one pin and the blast happens, and it's just a very rapid and very fast process. Now we have application in photosynthesis. Green plants that converts water and carbon dioxide into carbohydrates, and this process is definite. Definite as photosynthesis. The reaction uh, is given as. Next, we have a redox titration. Redox titration is basically reaction that between the analyte and the titrant is an oxidation. Next, we have application method, that is accurately telling that the samples and the ions and all that. Next, we have electrolysis. In order to predict the product of electrolysis, we first need to understand what is electrolyte. We have to know what is electrolysis. And electrolysis is a method of separating bonded elements and compounds by passing an electric current through them. It uses a direct electric current, like we can also call as DC current, and this is an electrolyte at DC supply, two electrodes, and electrolytic cells. It is a cell that converts electrical energy into chemical potential energy, and this is known as electrolysis. Faraday's first law, it's a brief explanation, but it is clear that the flow of current through the external battery circuit fully dependent upon how many electrons get transferred from negative electrode and cathode to positive metallic ion are cations. If the cations have valency of 2 like Cu plus means 2 positive, and it's have also a negative electric charge which is 1.62 into 10 raised power 9, and coulombs, according to coulombs it is minus 1, and minus 2 charge transfer from cathode to anode. Next, we have the first law of Faraday's electrolyte states that the chemical deposition but to the flow of current through an electrolyte is directly proportional to the quantity of electricity. Next, Faraday's second law of electrolysis, which is also stated that the chemical deposition due to electrolysis is proportional to the quantity of electricity that passes through the electrolyte. The mass of the chemical deposition due to electrolysis is not only proportional to the quantity of electrical process through it. Again, we have our explanation, and now we have the Faraday's second law of electrolysis that states that the same quantity of electricity passes through several electrolytes, but the mass of the substances represented are proportional to their respective chemical equivalents and equivalent weight. Next, we have electroplating, which is a process plating one metal onto another by hydrolysis, most commonly for decorative purposes to prevent corrosion of the metal. We have a following types of electroplating, like we have mass plating, we have a rack plating, we have a continuous plating, we have a line plating. Now we have electromagnetic radiations. It is the energy that is propagated through free space or through a material medium in the form of electromagnetic waves such as radio waves, visible light, and the gamma rays. The Scottish physicist Maxwell Clerk was the first man who predicted the existence of electromagnetic waves. In 1864, he set forth his electromagnetic theory, proposing that light, including various other forms of radiance. And here is the second scientist in 1877 who provided the experimental confirmation by producing the first non-electromagnetic waves and demonstration. And here is a magnetic field. We have electric field, in it we have a magnetic field in it, and we have a wavelength which is inversely and directly proportional to each other. Basically, it is established that the time varying electric field can induce magnetic field, and that time varying electric fields can, in like manner, induce electric fields because such electric and magnetic fields generate each other. They occur jointly and together they propagate as electromagnetic waves. Next, we will learn about main difference continuous spectrum versus line spectrum, in which the spectrum is set for the wavelength and its characteristics of radiation which is emitted are absorbed by a particular object, substances, atoms, or molecules. Now we have a radiation chemistry. Radiation chemistry is a branch of chemistry and a subdivision of nuclear chemistry. Radiation chemistry studies the chemical changes resulting from the absorption of high energy ionizing radiations, for example, alpha particles, electrons, gamma rays, protons, and heavier charged particles. We have a types of ionizing alpha, beta, gamma, and X-rays. Alpha radiations, we have the explanation of it, and next we have a gamma, we have beta, and we have X-rays. This one is the gamma radiations, and this one is X-rays. Now we have a nuclear stability. Nuclear stability means that the nucleus of an element is stable and thus it does not decay spontaneously, emitting any kind of radioactivity among the nuclei expected to exist, and they presently only 195 are stable against spontaneous decay because of energy conservation. Ionization is the process by which ions are formed by gain an atom or molecule. If an atom or molecule gains an electron, it becomes negatively charged, and if it loses an electron, it becomes positively charged. Energy may be lost or gained in the formation of an ion. Next, we talk about half-life. Half-life is the time required for a quantity. Time required for a quantity to reduce to half of its initial value. that the physicists to describe how quickly unstable atom undergo or how long stable atoms survive radioactive decay. The term is also used more generally to characterize any type of exponential or non-exponential decay. For example, the medical science refer to the biological half-life of drugs and other chemicals in the human body. The converse of half-life is doubling time. Next, we talk about radioactive chemistry, which is the emission of particles from nuclei because of the nucleus and its instability, reducing the radioactivity. Next, we have a nuclear chemistry. Nuclear chemistry is a subfield of chemistry dealing with the radioactivity, nuclear process, and transformation in the nuclei of atoms, such as nuclear transmissions and nuclear properties. It includes the study of the production and use of radioactive sources for a range of processes, spontaneous fission. It's a form of radioactive decay that is found only in very heavy chemical elements, in which we have a small nuclei or nuclear particles that are possible and the great atomic mass numbers. Photoelectric effects, it is a emission of electrons or other free carriers when the electromagnetic radiations like light hits a material from this perspective and can alteration in the intensity of light induces change in the magnetic energy of the electron emitted from the metal. Compound effect is a name given by physicists to the collision between a photon and an electron, and the production is the creation of a subatomic particles and its antiparticle from a neutral person. Example include creating an electron and a positron, a mone, and an antimony. Annihilation process in particles. Physicians say the process occurs when the subatomic particles collide with the respective antiparticles to produce other particles uh, such as two photons, total energy and momentum of the initial pair are conserved in the process and distributed among a set of other particles in the final state. Antiparticles are exactly opposite and two quantum numbers for a particle, so the sums of the quantum numbers are they are also highly particles and they are particles that are created. Now we have radiation energy. Physics radiation is the emission or transmission of energy in the form of waves or particles through a material medium. This includes electromagnetic radiation such as radio waves, microwaves, X-rays, gamma rays, and infrared radiations.